tell me something that's true about the children?
The left number is always one more than the...
Very good. The one on the left is always exactly one more than itself. Is that true all the way throughout?
Yes.
So that's one way for a parent to know whether one of its children is right below it. If that child's number is one more than its own, which one is it?
It's left.
It must be its leftmost one.
Unless it doesn't have one, then it's the next lowest, or the next highest.
So if it doesn't have one, actually, it never would have been asked to replace that one, because the one, some level above would have figured out that it actually is down another branch. How would number 1 know that number 5 was one of its children?
Because it fits the numbering pattern.
It would have to.
Just count plus its number plus.
Can you say it's in between its leftmost and rightmost number? So you know it's one of its children?
Yeah. So if you can calculate all these numbers down here, then you can figure out which branch a particular child is down. How would number 1 know that number 9 is down its rightmost branch?
It would have to.
Because its
count.
rightmost branch is 8, and then 8 is one more, or one less than 9.
It just knows that 9 is greater than 8. It knows that 8 is this child here, and it's greater than 8, so it's going to ask 8 to replace number 9. Actually, it's going to ask 8 to replace number 1.
So when you run count, or you do like a count operation, it'll tell you everything that's in the entire tree, right? The number of everything in the tree.
Yep.
And so how do you actually find an individual node using count?
Like how do I find number 5?
So if you ran a count on that entire function there,
Right.
You would get 22.
Correct.
So how would you actually find 5 using that?
Well, I would ask this one, get me number 5.
Okay.
Remember the exercise we did last time? Give me number 4. This one goes down here and goes, give me number 4. And this one here goes, oh, there it is.
Okay.
So it just, again, it's like the CEO that doesn't know the full answer, but it knows that one of its VPs has got to know. So it just passes off that says, I don't know, but here, you figure it out.
Okay.
And I'll subtract 1 for myself because I know it's not me.
So you take in a value and then just count until it reaches that value?
Kind of.
What do you do?
Huh?
Never mind.
Okay.
So the count for 8 to know that there's a 9 or for 1 to know that 8 has a 9 or a 10 below it, the count has to be bigger than 8.
Right. But it doesn't know how far down, but all it'll do then will pass along the request to the next level down, and then that one will figure out which branch it goes on.
But if it's less than 8, if the count is less than 8, then it passes it over to the other side.
Right, then it must be somewhere over here. That's got to figure out.
It goes over to the right side, over the 0.
If it's less than 8,
If it's looking for 9 and the count is less than 8, then it sends back up to its parent. 1 sends up to its parent to
No.
somewhere else.
So 0 would have figured that out first.
Oh, right.
How does 0 know that 9 is down the left branch and not down the right branch?
Same way. Count plus.
Yeah. So it knows this number is 11 by doing some calculations, and since 9 is less than 11, it must be down this branch. If number 11 gets asked to replace number 9, it should go, I mean, the answer is you programmed it wrong. This one should never be asked to get number 9 because it should have been over here.
And there's out of bounds.
Yeah.
So So should you create like a new method called like search or something like that
Nope.
works a little differently than count, or does count actually?
Well, so replace will be similar to get,
Yeah.
but instead of it going all the way down and finding that one that you're looking for, it only goes down as far as the parent, and then it stops, and then does the work.
Okay.
So get goes all the way down to the one you're looking for. Replace, you go only down to the level right above it.
Okay.
So the key part to replace is figuring out, identifying whether a node is, in fact, the immediate parent to the one you're looking for.
Is get the one you gave us?
Yes.
Oh, okay.
So you can kind of structure replace kind of like that.
Okay.
You won't be able to just copy and paste it in because it goes too far.
Yeah.
Your conditions need to stop one level above.
Okay.
How's this one doing? Oh, we got 5.7.
It looks like it's actually kind of lined up with those ones.
Got one for sure.
So what this is not doing is drawing out the best one that it's drawing out. It's not drawing this one. But it must be the one that, the path that curves here, right? Because that's the only one that goes anywhere remotely close to this one.
I think it goes to the,
Oh yeah, it goes,
goes to that one first.
it goes like here, and then here, and then here.
Okay, that's the longest path possible.
See, but I don't,
It's definitely not the best.
I don't penalize it for taking the long way around. I only reward it for getting there.
It's the survival of the fittest. You do it, eat them all.
Unless he dodged all the ghosts that were running around.
See,
How do you
that's
reward
a
it?
slot.
By,
Don't understand.
It survives.
Use it cookies.
by giving it a rest?
By resetting its step counter.
Plus earlier, you can
So it has 1,000 steps to find one of the targets. If it finds one within 1,000, it resets that back to 0, and now has 1,000 more to find the next one.
Like a monetary reward.
So it's kind of like food, right? You've only got enough energy to go 1,000 steps, and if you don't find your food within that first 1,000, you're dead. But if you find it, you get to eat the food,
Then you add another 1,000 steps.
and then you got another 1,000 steps to find the next one.
Sounds good.
Sounds like a dangerous world.
Find it in 100 steps, and then you can add another 100 steps.
Yeah, that's easy to do. I don't think 100 will get it there.
Well, it's the first one, like.
We got one already.
Boom! I found one, but you didn't give it
But I
500
wasted
more
too
steps.
many.
See, it's gonna keep.
Oh.
Got two.
Wait, 500. I reset it back to.
More
Oh, it should be back
serious,
to 0.
more focused.
Ooh, got one again.
So it took 500 basically to get there, and then another 500, and then it stopped.
There it is. I like that. Maybe you can make it exponential. Like the first one, we have to find it within 100. So you make sure they try to get that first dot. The next one is 1,000.
What I want to do,
The next one is 100,000.
what I want to do is I basically want to give you this part of the program, but I need to clean it up. It's a total mess right now, and I need to modularize it some more so that I can separate the idea of testing the function from drawing it. Once I can do that, then we can get this to go much faster if I don't draw it. If I just run them, and maybe only show the best ones. Right now, drawing it and testing it are intertwined. You can't do one without the other.
Oh, that's my favorite.
And then I also want to separate it out so that I can make an interface called robot. You have to implement a method called like, generate robot, test robot, something like that. So I'll give you the part that actually draws it on the screen, but you define how to actually do the evolution part of it. Like, right now I've got it so that you give it an array of functions and tell it how many of the best ones you want, like I want 5, and then it returns the top 5. And then from that, you figure out what to do with those top 5 functions in order to generate the next generation of them. You know, do you want to just mutate them? Do you want to generate 100 of them, run all 100, and then return the top 99? It's up to you. So I want to separate out the testing it from the generating the robots also, so that what I give you is the part that just runs the tests. You actually define what a test is, define how to compute the best fitness, and how to generate the next set of robots to run. How's this one doing here?
Easy.
Okay, so the last thing I want to show you is, I think it's the last thing for today, is let's put this back to, what was this, 5? Right? And then was there a 6 below it? And then for our purposes, I'll take this. Uh-oh, that means I need to renumber everything. Forget it. I'll just, this doesn't have a code pad. I can't just try stuff. Actually, I kind of,
Blue Jay.
well, but I don't have the current version on Blue Jay. Actually, you know,
You program a code pad?
it almost does kind of have a code pad. It's called a scrapbook. So let's go new, and then you go other, and under Java, I think, is it here? Scrapbook. We'll call this scraps. So this is almost kind of like the code pad, except that, so you can just type in statements. You can go 5 plus 4, except that you highlight it, and then you say execute. No, I thought it would do something. So, semicolon?
You do a science. Looks like.
I used to know how to do this. No. I thought what you did is you highlighted it, and then you went execute, and then it either would display the result down here, or it would put the result on the next line. Well, let's do this. System.out.println. Highlight it. Yeah, there we go.
Do you have to highlight it in execute, or you can just hit execute?
Well, because what you can do is you can put a whole bunch of stuff in here. You put all sorts of things you want to do, and then highlight the one that you actually want to run. Or I think you can just say execute, and it does the whole thing from top to bottom. But the idea is that you can put little snippets or little scraps of code in there, and then selectively pick which ones you want to run. So in that respect, it's kind of like the code pad with a memory, but it's a little less convenient because you can't just like type in an expression and see what the result is. Okay, so what I want to do is I want to go expression E equals new constant 5. I'm going to go E dot system out define E dot get 0. what should I expect to see?
5.
5.0? Expression f equals new, let's say, add new const 5, new const 10. Out line f dot get 0. What should I expect to see?
5 again.
15.
15?
There,
5?
5.0.
5.0?
5.0.
What the?
So it's a 2 string.
I'm not evaluating it, I'm just saying get number 0.
Oh, so it's giving you the whole thing now?
Yeah.
Not just the value of the 0th place?
Add new mult, new const. Oh, g dot get 0. So if I do that one, what should I see?
Multiply 20 plus the other one,
What's that? Say again?
times 20 plus with that other,
It can't Pringle.
with that.
Oh. So I should see a mult
Well, plus
Multiply?
first,
plus first,
right,
because of this.
yeah, and then a new multiply, so then a multiply, then the whole f, and 20. Which is another plus.
You add new mult. What did it say? Oh. Add needs two things.
Constant.
There.
It's called constant. It's just
All right, what's it doing now?
Didn't it run the first two? Or does it
Yeah,
not remember?
and on the first one. All right, this sucks. Okay, what I really want to be able to do is this. Remember these? The testers? So I set up an expression, and then I say if I do a get 0, I should get back basically the same thing. If I set up an expression with a variable and I say get 0, I should get back the same thing. Set up an add with 5 and 10, and I say get 0, I should get back the same thing. If I say get 1, I should get back 5, and if I say 2, I should get back 10. Okay, and then it just goes from there. I can run this. And get the green light, so it'll all work. Okay, the reason why I bring this up is what is assert equals actually doing to compare two things? How does it know that two things are actually equal to each other?
It evaluates both of them.
Okay. evaluating and what you expect. So let's call this E1 and E2. And then all it does is it does return E1 is equal to E2. True or false? Okay, there's some problems with this. What's the type of E1?
Constant. It's gonna be like an integer.
If I was to define this method, I'd have to put a type here. What would I put?
Object.
Object? Double? String? Int?
You're evaluating.
Can you see this?
Mhm.
Okay, there is, let's find out. There is an assert equals that compares two doubles. There's an assert equals that compares a double to a double and then how close they can be together. There's an assert equals for longs, an assert equals for an object array, an assert equals for just an object, assert equals for strings, assert equals for strings, doubles and doubles and doubles, assert equals for strings, longs and longs, strings, object arrays, so
So there's a lot of them.
there's a lot of them.
Yeah.
For kind of like all the common cases here. But the one that handles most of them is this one right here. It takes in an object and another object, and it compares them. So if this is object, and this is object, what does this do?
Evaluates the object.
Okay? And what does it mean for two objects to be equal to each other like this?
They have to be the same.
Same number of characters.
They have the same value.
What do you mean by the same value?
Well, I mean, if one of the objects is like Barry and the other one is Barry, then they're equal to each other.
Nope.
No?
They're the same thing.
What'd you say?
They point to the same place.
It means E1 and E2 point to the same memory location.
So what you gotta do is, do the double one with, E1.eval. E2.eval. Instead.
Well, that would mean that these two objects evaluate to the same thing, which is not really what I want. Jason?
So when we're evaluating this, do we want to evaluate for equivalence? Do we want to evaluate for, are they exactly the same?
So I'm going to say if I give you these two plus, 5, 10, 5, 10, I want you to say that these are the same expressions.
But they can be at any location, at two separate locations. on
Right.
the tree.
Right. So I'm going to say that
So-
these two trees look the same.
So then,
So if I do plus 5, 5, although they evaluate to the same value, they're not the same expressions.
so they should not be equal.
Return false.
Not be equal. I mean, as far as the result of them.
Well, as in assert equals should fail because they're
Oh,
not the
yes,
same.
these are not the same. So
Okay.
this should be false.
So then the second question in follow on to that is, are we going down to the sort of assembly level of equivalence?
Kind of.
Okay.
So if we just do this, this is just simply saying object 1 and object 2 occupy the same spot in memory,
Right.
which is not what we want. So this is not the way to compare these two objects. And we can't do E1.eval equals E2.eval,
Then that'll be true.
what?
Then that'll be true.
Then this would be true, but in fact they're not the same expressions. So we can't do it that way. And also this means this assert equals only works for our particular program. Because only ours know how to do evals. So we can't do that. We could do E1 dot equals E2. Have you seen this? This is in fact a better way to compare two objects. You're asking E1, are you equal to E2? Well, it turns out the default behavior for dot equals, and all objects know how to do this comparison. So dot equals is a method of object, so every class you declare has a method called dot equals. So if you go and you look inside the definition for dot equals, all it does is it says, inside of here, it goes if this equals E2. So it says if my address is the same as the address I was told to compare myself to. Well, that's no better than we had before.
Seems like there's a lot of equivalence here that's really just about checking addresses.
Yeah. So we don't want to do this. But since this is a method of object, we can redefine it. We can redefine what it means to be equal.
So we gotta write our own.
We gotta write our own. So what does it mean if I have a constant 5 and a constant 5? What does it mean for these two things to be equal?
They both evaluate to the same thing.
Not quite, because then these would be the equal. So if I gave you a constant object 5 and a constant object 5, and I said, are these the same? You'd probably say yes, even though they're different objects. So what does it mean for them to be equal to each other? Maybe
They're the same type
shape, so the same
they gotta be the same type,
and have the same
right? So if
value.
I gave you a constant and a variable, that's definitely not equal.
So the value has to be found in the same way.
Same type and
The value has to be found in the same way, so they have to go through the same process to achieve that value.
well, if I gave you plus 2, 3,
Yeah.
those are not the same.
But they have, so basically.
No,
the
they're
numbers
not,
then-
so that's
So one
why
thing, they're
they're.
not the same type. This is a constant, this is a plus.
And 5 was just achieved by just putting in
If I
the
gave you
5.
plus 3, 2, those are
Nope.
still not the same.
Usually all of their characteristics are the same,
What do you mean by that?
like,
Same order.
data types within.
Same type?
Well, like within, like the, member data.
Member data. What does that mean?
Isn't that like the global attribute, or the global variables in the class? All of them are the same.
Oh, like when you define a class, you have value, or like the add has expression left and expression right. You're getting there.
Aren't those just
You can do
lists?
a series of if statements, and if they all prove to be true, then they're the same, right? So at first you ask, are you the same size? And you ask, do you evaluate to the same thing? Then you ask, is left the same size as my left? And go and it goes from there.
So if I put this back to the way it was. So we can say these two expressions are the same if these are both the same type,
Yeah.
and if everything to the left looks just like the everything to the left over here, and everything to the right over here looks just like everything to the right over here. So they gotta be the same type. For constants, they should have the same values. That's pretty much it. Let's go look at const. Here's my equals. Oh, I need to fix this. Hang on. This is wrong. here's the equals method for a const. If the other thing, which is the thing that's being passed in, is null, it is clearly false. So if I'm given a const and a nothing, those are definitely not equal to each other. The other thing has to be the same type I am. Since this is defined within const, the other thing also has to be a const. If it's not, they are definitely not equal. I can stop right there. And the last thing is, if my value is equal to the value of the other thing. So if my value, 5, is equal to the value inside of that one, then they're the same. So this makes sense here? There's 3 checks to do. If the other thing is null, definitely not the same. If the other thing is not a constant, definitely not the same. And then if my value is equal to the other's value, then they are the same. And if they're not equal to, it's false. Okay, does that make sense? Okay, why do I have to do a cast here?
In order to cast into object.
Because it came in as an object. So dot equals ought to be callable on anything. I'd be able to pass in a const and a string, and it should work.
So you want us to do one of these on each of our...
Yep.
All right.
Yep. So once I establish that the thing that's being passed in is a const, then I can cast it to const, and then go fetch the value.
Okay.
Okay, one thing should look a little strange here. A little strange is that value is private. You see that? Value is private. And yet, I can just go look at it.
Why is that?
Isn't it part of the same class though?
Yeah, it's the same, I'm a const and it's a const, so actually I get access to it.
So what happened, can I ask, you were talking about the 3 different little subtrees in each comparative object, and they were different. That doesn't really apply.
Well, so let's go take a look at like add. Well, let's look at let's go look at add.
Oh, that, you're talking about only for constants?
Yeah, this is only for const. So 2 constants are the same if the other thing is a const and its value is the same as my value.
The instance of, how does that work? You guys not?
So this is a new thing you probably haven't seen, but it basically checks what type of thing a variable is and tells you whether that's true or false. So it says, is other an object of const? Okay, let's go look at add. Tell me what this does.
Checks to make sure there's something there.
Check to make sure something there.
Returns the instance of the.
So it checks to make sure that other is an object of add.
Okay.
So make sure this is basically checking the type.
To make sure it's an okay, make sure that it's an add.
Yeah.
And it's dot left equals add other dot left. Let's make sure everything on the left is the same as the other one's everything on the left. And everything. So it's just checking. It's making sure they're the same type, making sure that all the things on the left of this type are the same as all the things on the left of this type, and all the things on the right are the same as all the things on the right.
But it doesn't do so by actually walking down that whole tree. It just passes
Just
off
adds
the
them up.
job of checking equality to the thing on the left.
Right, because the whole point of the third is that you operate on yourself and
Right.
pass jobs down.
Yeah, so I just check to make sure that the other thing is an add. And then I ask my 2 branches, are you equal to the other one? And are you equal to the other one? And if they both come back and say yes, then I can say the whole thing is yes.
Provided that you are also equal.
And that means I have to define equals for add, for
So
all
you're
the-
saying it just asks the top branch what your count is, and it's comparing the 2 counts.
There's no count anywhere.
Oh, okay. Well, what's the,
It's saying that an expression tree is equal to another expression tree if the two top pieces are equal, which is, or actually, for an add, there's no value to check, so we're
Yeah,
just making
so
sure
they're
that both of them are an
pluses.
add. And if the left branch of the first tree is equal to the left branch of the second tree, and the right branches are the same as well.
so then it does that by asking each one down.
Yeah, if
Okay.
they're equal. And so this whole chain of equals is going through. So you're basically asking trees to test whether they're equal to each other by checking their subtrees. Each one of those is checking their subtrees.
Similar way to how count counts.
Yes. Similar way to the way count counts, the way get gets.
So recursive.
Yep. Let's go look at mult. Should look almost identical. What's the difference?
You put in mult instead of add.
Yeah. If positive, it looks almost identical. Yes?
How come you have that, on the this dot left, other, you cast it for like the molt, you have to cast it as a molt? See how you did that, the one in the gray?
Yeah, if I didn't cast it, like that,
Yeah.
then all we can say is that other is an object.
Which means
And
that,
objects,
but what could be on the left isn't necessarily molt, right? Cause like this dot left dot equals, and then you cast it other as a molt. What if it's not a molt, you don't have to?
Right, but it's not gonna get to that point if it's not a molt, cause it tested for if it's a molt above.